A right cylinder, a right cylinder can made of metal needs to be constructed to hold 300 cubic centimeters of volume. Find the dimensions of the right cylinder metal can that will minimize the cost of production. So the height is h, the radius is r, as we see in the diagram there. There's the volume of a cylinder, the area of the sides, and the area of the circles on the top and the bottom. Formula. So basically, we know how much we need to hold. 300 cubic centimeters of some liquid, like a soda can or something, or a big container of holding oil or something like that. We know how much we need to hold, and we'd like to minimize the cost of production, meaning that the material, the metal we need is that, because there's options, right? You could make it tall and thin, or you could make it more like a tuna can, short and wide, or there's something more in the middle. Which shape is going to make the least amount of material on the outside, still holding the volume you need? Very practical question. Well, it says out here the formula for the total surface area of the metal can, top, circle bottom, circle sides, in terms of R only, not H, is now how'd they come up with that? We're just doing the setup on this one. We're not going to actually get all the way to the final answer. So anyway, we need this is surface area. So um, surface area. Well, what is all the surface area? Well, there's a circle on the top and a circle on the bottom. Top plus bottom. And then there's the sides. The sides go all the way around. It's not really right side, left side. It's all the way around, right? So the top and the bottom are just circles. So it's just pi r squared, pi r squared. And then the sides, you can read my scribbling writing here. The sides is 2 pi r h. 2 pi r h. Okay, so there it is. The only thing is it says not H. We don't like this H right here. We're happy with everything else, not that H. What are we going to do? Well, we have another relationship we haven't used yet. There. It says to hold that much volume. So we say, oh, the volume, which the volume is right there, pi r squared h must equal 300. So you see what we can do, right? We solve for h here. Divided by pi r squared. Boom, boom. We get h, 300 pi r squared, and we plug that in right there for h. So then bringing this down, surface area will be pi r squared plus pi r squared. That's 2 pi r squared plus 2 pi r, and then h. And what is h? That's not a very good 3. 300 over pi r squared, and that's what they got. 2 pi r, 2 pi r squared. So there's the surface area formula in terms of r only. So that's all we're going to do on this problem is the setup. So there's another problem where you go on and you finish it and you take the derivative and then set it equal to 0 so you can find the r, the radius, that'll make the can have the minimum surface area, minimum metal to hold the volume you need. Very practical question used by shipping container people. And there we go.